The first module, Module 1, is Introduction to Big Data. The first slide talks about the rapid growth of big data. The primary drivers of big data are cloud computing. The second one is clustered and distributed servers. And the third one is the Internet of Things. Advances in sensor, cloud, and machine learning technologies are transforming industries and business models. The first primary driver, that is, the cloud computing, brings about a high level of cybersecurity and data governance. The second primary driver, which is the clustered servers, provides fault-tolerant and distributed services. The third primary driver, the Internet of Things, provides massive amount of clickstream data that supports machine learning. The healthcare industry were the first ones to latch on to big data. They are the biggest users of big data for the following reasons. They have large amounts of big data and a structured data which they use to provide treatment options. They need to provide fast, efficient, and distributed processing, as is provided in MapReduce, as we will learn later. They need to exploit cybersecurity and encryption practices, as is found in cloud computing. Please refer to the picture provided by the International Data Corporation on big data growth. It shows they have a steady pace of growth at 12% increase annually, starting 2016 going up to 2020. The next slide is on big data definition. It is important to understand what big data is. This is a term loosely used to define structured data, as we would find in relational databases, semi-structured data, as we would find in key value pairs, for example, in the Mongo database, or unstructured data, as we would find in emails, text files, log files, videos, etc. Now, this kind of data inundates the business on a day-to-day basis. Here, we are not looking for the volume of data. We have that. But what we are looking for is how this data can be analyzed for insights that lead to better decisions and strategic business moves. In order to do that, we have to take this raw big data, which obviously comprises of structured data, semi-structured data, and unstructured data, and collect this data in the form of a data lake. And the next and the most important step is to find the business value hidden in heaps of structured and unstructured data. So what we did initially was to take the data and transform it into binary digital form so we could process it efficiently in our computer systems. But now, once it has been processed, we need to determine how to get information out of it. And what makes this raw big data information is when we apply business rules to it and implement quality on this big data, which basically is referred to as 360-degree view of data. So that's what yields the information. So what is information? Information is raw big data plus business rules plus quality. What is that information does for us? Information is what drives the business intelligence. So that is the importance of information. Once we have it in the form of information, the raw big data has been transformed into a form of information. It will drive the business intelligence which is needed by the business decision makers. Now let us look at how do we implement big data. As we know, it is complex and has a complex implementation. It comprises of the tools and techniques, which is generally referred to as the Hadoop ecosystem, the infrastructure, which is essentially the node cluster and the Hadoop distributed file system, and processing, which is provided by MapReduce. The next slide is on big data projects. At this point, we find that the technology and business conditions are ripe for big data projects. Technology companies are joining hands to develop powerful solutions. A case in point, Cisco is partnering with NetApp. Cisco, the network giant, NetApp, the storage giant, if you will. They both have combined to create a unified computing, storage, and network infrastructure, which is composed of Cisco Unified Computing Systems and clustered network architecture that uses NetApp's fabric attached arrays. Now, the nature of big data is such whose scale, diversity, and complexity requires a different architecture, techniques, and algorithms to manage and extract hidden knowledge from it. As we are on the topic of big data projects, we will look at what types of projects do we have. At a high level, there are two types of big data projects. There are storage-driven projects or application-driven projects. The organizations that are running internal corporate applications in a private data center are faced with very large volumes of structured and unstructured data. That is precisely where the in-house Hadoop infrastructure comes into play. And these are the storage-driven projects. The second kind of projects are the application-driven projects. These primarily use fast and distributed map-reduce processing. These are those companies that provide big data analytics where processing speed, as is provided by map-reduce processing, is of primary concern. As we will learn in cloud computing module, these projects will integrate with cloud providers' security measures. They would start with a cloud environment and will integrate with the cloud providers' security measures by integrating the big data platform with the encryption and security practices inherent in the cloud environment itself. Now I would like to refer to a quote from the Cubole Big Data Activation Report. It is important to use the right tool for the job at hand. 76% of organizations actively leverage at least 3 big data open source engines for data preparation, machine learning, and reporting and analysis workloads. The data that as the size of implementations grow, data-driven companies constantly seek to improve the ratio of users per administrator, thereby reducing the incremental cost of growth and increasing user self-sufficiency.